Today we are going to discuss about electrostatic fields. To understand the fundamental concepts that is applicable to static electric fields in free space or vacuum. Static electric field, that is time invariant in nature. That means in respect of time, the electric field that does not change itself. To study how charges interact with each other, and this can be done using the concept of field, where both are created by charges. As we consider gravity as our first field, and here we are going to discuss how electric charges creates electric fields and how those electric fields in turn exert forces on other charges in vicinity. We can say that the electric field is completely analogous to the gravitational field, where mass is replaced by electric charge, but there is a narrow exception here. The first exception is charges can be either positive or negative, whereas mass is always positive. And the second exception is masses always attract, but similar charges repel each other. An electrostatic field is actually produced by a static charge distribution. That means charges that are involved here is static in nature. There is no motion involved with these charges. Basically, electrostatic fields are governed by two fundamental laws. Those are, first one is Coulombs law and second one is Gauss law. First we will understand and thorough explanation of Coulombs law. This law is about the force a point charge exerts on another point charge. And this law is independent on the polarity of charges. That means charges may be similar in nature or opposite to each other in nature. Means there may be two positive charges or two negative charges, or maybe positive and negative charges together. All these three cases Coulombs law is applicable. Coulombs law states that the force between 2 point charges, say Q1 and Q2, is along the line joining them directly proportional to the product Q1 Q2 of the charges and inversely proportional to the square of the distance r between them. If two point charges Q1 and Q2 is there, then the line joining them means the distance between these two charges, if we say it is r, then the force acting here in between is inversely proportional to the said distance r and directly proportional to the product of charges Q1 Q2. Now the mathematical expression can be explained as, if we consider the force between 2 point charges is F Newton and 2 point charges are, one is Q1 Coulomb, another is Q2 Coulomb, and the distance between 2 point charge is r meter. Here in the figure shows the Q1 charge, Q2 charge and the distance between them, that is r. Then as per the Coulombs law, the force acting between the charges F directly proportional to the Q1 into Q2, and as per the Coulombs law second principle, the force acting between them is inversely proportional to the distance between two charges, that is F varies as 1 by r square. So combining these two, that is F varies as Q1 Q2 and F varies as 1 by R square, we can write as F varies as Q1 Q2 by R square. Now we can write F equal to K into Q1 Q2 by R square. Here K is the proportionality constant, and the value of the proportionality constant depends upon the system of units we choose. As we consider units of all the above parameters are in SI system, so that value of K will be K equal 1 by 4 pi epsilon 0. Here epsilon 0 is a constant and it is called permittivity of free space. That means permittivity means the how much electric flux or electric field lines can be passed through this free space, where permittivity of the free space can be expressed in SI system, that is Farad per meter. The permittivity of free space has an absolute value and it is about epsilon 0 equal 8.854 into 10 to the power minus 12, and the unit will be Coulomb square per Newton meter square. That is equivalent to 10 to the power minus 9 by 36 pi farad per meter. So value of proportionality constant here K will be as K equal to 1 by 4 pi epsilon 0. Equivalently, we can write as 9 into 10 to the power 9 meter per farad. So finally we can write the force F between 2 point charges Q1 and Q2 and charges that are apart from each other, that is R meter, and putting the value of proportionality constant K, that is 9 into 10 to the power 9 meter per farad. So the force acting between the charges F equal to Q1 Q2 by 4 pi epsilon 0 R square. Thanks for today. In next video we will learn force due to several point charges, electric field intensity and principle of superposition.